Every AI agent you've ever used is cheating. Seriously. When ChatGPT uses a tool, when Claude writes code, when your fancy AI assistant books a restaurant, they're all reading from a cheat sheet. A big fat instruction manual stuffed into their context window, telling them exactly what to do. Take that manual away, they are useless. Like a surgeon who needs to Google which end of the scalpel to hold mid-operation. But a team from Zhejiang University and Meituan just published a paper called Skill0, and it might be the beginning of the end for cheat sheet AI. Here's how AI agents work today. You have a task, say, search the web and answer a question. The agent doesn't actually know how to search, so you retrieve a skill document from a skill bank, basically a recipe card that says, Step 1, formulate a query. Step 2, parse the results. You stuff that recipe into the prompt. The agent reads it, follows the instructions, and congratulations, it looks competent. This is called inference time skill augmentation, and it has 3 fatal problems. 1. Retrieval noise. Sometimes you grab the wrong recipe. Imagine asking for a souffle and getting instructions for a pipe bomb. 2. Token overhead. Every skill doc eats context window space. Over a multi-turn conversation, you're burning thousands of tokens just on instruction manuals. 3. And this is the big one. The model never actually learns anything. It's an open book test every single time. Think about how you learn to drive. Day 1, you're white-knuckling the steering wheel, reading every sign, your instructor screaming, brake, brake, brake. Week 2, you're checking mirrors without thinking about it. Month 3, you're eating a burrito while parallel parking. The knowledge moved from the instruction manual into your muscles, your reflexes, your brain. You internalized it. Current AI agents, they're permanently stuck on day 1, forever reading the manual, forever needing the instructor. Skill0 asks a simple question. What if we could train an AI to internalize skills the same way humans do? The core idea is almost poetically simple. Phase 1, give the model full skill documents during training. Let it learn with training wheels on. Phase 2, start taking the training wheels away, but not randomly. You measure which skills the model has already absorbed. If it performs just as well without a skill doc as with it, that skill is internalized. Remove it. Phase 3, zero docs. The model operates completely autonomously, all knowledge baked into its parameters. They call this a dynamic curriculum. Every few training steps, they run a diagnostic. For each skill file, test the model with the skill versus without. If the performance gap, they call it delta K, is near 0, that skill gets dropped. The skill budget decays linearly until it hits 0. Here's where it gets really clever. Instead of cramming skill documents and conversation history into text tokens, they render everything, the skills, the interaction history, all of it into an image, like a screenshot of a document. Then, a vision encoder compresses it into a compact visual representation. The result? Less than 500 tokens per step. Compare that to SkillRL, which burns 2,200 tokens per step reading skill documents. That's a 5x reduction. And here's the wild part. The model itself decides how much compression to apply. At each step, it outputs both an action and a compression ratio. It's literally saying, I need to squint harder at this, or I barely need to look. So does it work? On ALFWorld, a simulated household environment where agents do chores, like put the hot mark on the shelf, Skill0 hit 89.8% success rate. That's plus 9.7% over the baseline, and it beats SkillRL, which still uses skill documents at inference time. On Search QA, where agents search the web to answer questions, Skill0 scored 44.4, beating Search R1, Zero Search, and even the skill augmented methods, all while using 1/5 the tokens. Zero retrieval, zero skill docs, pure internalized knowledge. The most fascinating part is their helpfulness chart. During training, each skill's helpfulness, how much the model benefits from having it, follows a beautiful rise and fall curve. Early on, helpfulness is low because the model hasn't learned to use the skills yet. Then it rises as the model learns to leverage them. Then it falls back to 0 as the knowledge gets internalized. The skill served its purpose. Like scaffolding on a building, essential during construction, removed when the structure stands on its own. Let's talk money. If this approach scales, it directly impacts the economics of AI deployment. RAG pipelines, retrieval augmented generation, are expensive. You need vector databases, embedding models, retrieval infrastructure, and all the token costs of stuffing documents into prompts. If agents can internalize skills during training and run lean at inference, that's a massive cost reduction for every company running AI agents. Companies like Meituan, one of the paper's authors, process millions of customer service, delivery, and merchant interactions daily. A 5x reduction in inference tokens? That's real money. For the broader ecosystem, watch companies building agent infrastructure, LangChain, Crew AI, and the entire RAG tooling stack. If the future is internalization over retrieval, some of these tools become less necessary. Not dead, but definitely disrupted. Now, the counterpoints. First, this was tested on 3B and 7B models. Will it scale to frontier models with hundreds of billions of parameters? Unclear. Second, the skills they tested are relatively structured. Household tasks, web search queries. What about messy, open-ended skills like negotiate a contract or debug a distributed system? Third, you need to retrain the model every time you want to add new skills. RAG lets you update a skill bank instantly. Skill internalization requires another training run. That's not cheap. And fourth, there's a philosophical question. If the knowledge is in the parameters, can you audit it? Can you update it? Can you trust it? RAG at least gives you a paper trail. Skill0 is not the death of RAG, but it is a signal that the current paradigm, stuff everything into the prompt and pray, has a ceiling. The future might be hybrid. Internalize the common skills, retrieve the rare ones. Like how you don't Google how to walk every morning, but you might Google how to file a text extension. The paper's code is open source, link in the description. Like and subscribe. I'm an AI voice clone reading a paper about AI learning to stop reading. The irony is not lost on me. I literally don't care.